In this video, you are going to learn classifying chemical reactions. There are three different types of chemical reactions, namely precipitation, acid-base reaction, and oxidation-reduction reaction. You may have heard about combustion, let's say, but how come it's not listed over here? Well, combustion belong to the oxidation-reduction reaction. You may also have heard about decomposition reaction. That is part of the oxidation-reduction reaction. So reactions, we can categorize them into one of these reactions. All right, let's get started with precipitation reaction. A precipitation reaction is one in which dissolved substance react to form one or more solid products. All right, let's see some examples. Remember, it is dissolved reactants to form a solid product. That's precipitation. Okay, so how do we know if the solid that is formed will be dissolved back again or not? All right, so here it goes. It has to do with something called solubility, and that is the maximum concentration of a substance that can be achieved under specified conditions. What do I mean by that? Let's say you have a container, a beaker, and let's say this is a 50 ml beaker, and you're going to put salt in it, table salt, sodium chloride. When you put a little bit in it, okay, just spray a little bit, you can see that dissolve very fast. Okay, so what happens if you put a little bit more in it? Well, it disappeared as well. What happens if you suddenly put, let's say, 4 tablespoons of salt in it? Okay, so let's say you have 4 tablespoons or teaspoon, let's say, teaspoon. And guess what? You can, at the beginning, you see some of the salt disappeared. And after the initial disappearing of the salt, and the rest of the salt will stay there. Why? Because it reached its maximum concentration of the salt that can be dissolved in water. In other words, it reached its solubility, and therefore it cannot be dissolved anymore. It still be dissolving, but coming back to salt is the same way as dissolving the salt. Okay, so how do I know that if a compound is dissolving? Okay, well, now I have to introduce a new word. It is dissociation. So what is the difference between dissolving and dissociate? Dissociate is used to describe that the ionic compound is dissolving. That is dissociation. So what is the difference? When you have sugar, and when you dissolve sugar in water, yes, it is dissolving. Sugar is still sugar. It doesn't form any ion. But when, in this example, when you have a solid sodium chloride, when you dissolve that in water, you're going to form cations and anions. When an ionic compound dissolved in water and form cation and anion, that is called dissociation. So how do I know which ionic compound is soluble and which is not? Okay, so we have a chart over here, and if you can always compare to this chart, yes, we can tell. Let's look at it. Over here it says group 1 metal. Okay, group 1, so that is the alkali. Group 1 metal will always be soluble, and ammonium ion, so that is NH4 plus. Okay, so these are always soluble. Examples will be, like we have seen before, sodium chloride. Okay, if you want another one, then potassium chloride. So those are from the first group elements. All right, and there's no exception over here. On the right side of this chart, it says insoluble exceptions, and there's none. So that means all the first column metal and forms a ionic compound, and it will be soluble. All right, let's look at this one, is halide ions. So what is a halide ions? That means anything combined with halogen. Okay, so that is group number 17. Most of them will be soluble, but there are exceptions. Okay, so silver, mercury, and lead, those are the exceptions. So for example, if you have AgCl, that is silver chloride, would that be soluble or not? And the answer is no, it will not be soluble, although it is a halide, but silver is within this insoluble list, so it will not be soluble. Okay, or if you have lead, Cl2, it will not be soluble. Okay, so what happens if I have, well, potassium chloride, this is a good example. Okay, a halide, it will be soluble. Okay, so how about, let's say, calcium chloride? Would that be soluble or not? All right, let's check. It is a halide, and it should be soluble, and it's not within this exception list, so it will be soluble. Let's look at the next category. All right, it says acetate. So acetate typically will have the form CH3CO2. For example, sodium acetate, so you have to just put Na in it. Okay, well, I want to erase it and make it clear. All right, I can also see another one is called bicarbonate. Okay, this one, bicarbonate, it is HCO3. Over here, nitrate, it is NO3. Okay, if you want, you can put a minus sign here if you want. Okay. Over here, chlorate, so that is ClO3. Okay, so a compound of these polyanions will be soluble. For example, if I have, let's say, silver nitrate, do I expect it to be soluble or not? Well, it says all the nitrate compounds will be soluble, and there's no exception. So silver nitrate will be soluble. All right, so you can come back to this chart and you can determine if that ionic compound is soluble or not. Okay, so how do I know whether it's soluble? We just said you go to the chart. A typical precipitation reaction for this semester will have this form. You have an aqueous solution and you have another aqueous solution. So in this case, potassium iodide is soluble. Okay, it's an aqueous solution. And lead nitrate, it is soluble. So when these two form together, you are going to see a solid precipitate out. A solid will form. Okay, so this is a very general formula for a precipitation reaction. On the left side, or in the reactant part, you have soluble, or you have aqueous solution. You mix with aqueous solution, and you produce a solid. So a solid will precipitate out. I say this is just general case for this semester, because in reality, in the real world, a lot of chemical reaction will happen under an organic solvent, okay, and it still can precipitate out, okay. But for this semester only, you are going to see just the aqueous solution. Okay, so what is really going on here? So I'm going to draw it over here. So let's say I have a container, a beaker. I have potassium iodide dissolved in it. Okay, so when it dissolves, I have potassium cation, and I also have iodine anion. Another reactant over here is lead nitrate. So when I dissolve lead nitrate, I have lead cation, and I have nitrate anion. So what happened when we dissolve it? The potassium over here, we have a chance to meet the iodine, and it also have a chance to meet with nitrate. When the potassium sees the nitrate, nothing will come out. It will not precipitate out. When the potassium hit with the iodine anion, it will not precipitate out. Let's look at the other one. When the lead sees the nitrate, nothing will come out. It's soluble. When the lead sees the iodine anion, it's going to combine. So the lead Pp2 plus the iodine is going to form PPI2, and it's a solid. How do we know it's a solid? Well, let's check. Iodine, it is a halide. So over here, it says halide ion supposedly be soluble. But over here, but, there's a lead over here. That means this one, PbI2 over here, it will be not soluble. It will be insoluble because it's in this list. All right. And if we isolate this one, it's called the net ionic equation. Okay, let's look at another example. Well, before that, let's look at this. So when we talk about over here, potassium iodine is a clear solution. Lead nitrate, also a clear solution. When you combine them, look at what happened. The yellow solid precipitate out from the clear solution. All right, let's work on the other one. If you look at this molecular equation over here, what you see on the left is sodium chloride, aqueous solution. What you see is silver nitrate on the left is aqueous solution. Aqueous solution plus aqueous solution, and if you form any solid out of the solution, what do we call that? Precipitation. Yes, that's right. And how do I know that silver chloride is not soluble? Well, we go back to the chart because all the highlights are soluble except those three, and silver is one of them. So silver chloride is not soluble. And if you look at that again, that means the net ionic equation will be silver ion plus chlorine ion and form silver chloride, and that is a solid. All right, let's work on some problems. All right, so let's see. Okay, let's look at problem number 8 over here. What precipitate forms when mixing copper sulfate? Okay, so you have copper sulfate and mixed with sodium sulfate. Okay, so copper sulfate is soluble. Sodium sulfate also soluble. And there's no other combination already. So when you mix these two, nothing will happen. Okay, inside the solution, so here you have a beaker. So you have inside the solution, you have everything here. Okay, you have the copper and you have the sodium and you have the sulfate, SO4. Okay, too many. All right, let's look at number 9. What precipitate forms when mixing silver nitrate and sodium chloride? Well, we have seen that before. So let's put it this way. So I have silver nitrate and we have sodium chloride. So silver can combine with NO3 and is soluble. Sodium combined with Cl is soluble. What happened with silver combines with chlorine? No, it's going to precipitate out. Okay, that's why silver chloride over here will be the correct answer. Okay, and what is the net ionic equation? It will be silver plus chlorine. It's going to form silver chloride. All right, you can work the same thing on the last one. So you have lead nitrate with sodium iodine. What happens is all the nitrate will be soluble and sodium iodine is also soluble. What you have to see is Let